So the last couple of days, we were working with something called molarity. And molarity was a real simple equation. It was the number of moles of solute divided by the liters of solution. And you had a real simple equation. So molarity equals moles over volume, and we were able to put it into this triangle so that we know that molarity is equal to moles over volume. You can flip this around however you want it. Today we're going to do something very similar. In fact, it's so similar they're easy to get mixed up. What we're going to look at today is called molality with an L. In fact, you just saw me screw that up, so I'll try that one more time. Molality with an L. If molarity gets abbreviated with a capital M, we'll distinguish between molarity and molality by abbreviating with lowercase m. And the equation's very similar. It's going to look like this. Number of moles of solute per kilogram of solvent. And these two don't often interchange, so I'll be very specific about the ones I'm asking, all right? So the equation's real simple. Lowercase m, molality equals moles over kilograms. And of course, we can put this into a triangle as well. Be careful because we're using a very small m. And it's equal to moles over kilograms. This triangle works the exact same way, so that if you are asked to find kilograms of solvent, you can simply take moles over molality. Or if they're asking you to find moles of solute that go into a solution, you can simply take molality times kilograms. All right? I'll make sure I put this triangle near the top of any set of problems I'm going to ask you to try, but let's do a couple of examples. All right, let me get one here. Okay, here's a type of question you can expect me to ask. What is the molality of 25 grams of table sugar, otherwise known as sucrose? That's this stuff, and I'll help you out by telling you that sucrose has a molar mass of 342 grams. So that's how many grams are in a mole. And 500 grams of water. Now, I worked really hard to help you guys remember the difference between solute and solvent. And if you remember this crappy little diagram, especially with that clip from that movie Fantasia that YouTube wouldn't let me post, you've got your sugar cubes diving into your coffee, meaning it's the solute that solutes the solvent. So the solute is what is going in to the solvent. So make sure that you are putting those in the right place. All right? So here's how this question works. Obviously, molality is equal to moles of solute over kilograms of solvent. And this is clearly the solute. So we want to find moles first. And then we want to put this as our solvent down here. So there's a couple things that we need to do. First off, we need to get our solute into moles. So you guys know how to do that. How many moles of our solute C12H22O11 are 25 grams of C12H22O11? If we know that the molar mass is 342 grams in 1 mole. And you guys have been doing this since chapter 3. So I'm going to bust out my fancy schmancy calculator here. And we'll say, well, we don't want that, we'll say 25 divided by molar mass, 342. Here's how many moles of a solute we have, 0.073. Okay, we'll put that aside so we can put that into our equation. Now we need to get our solvent into kilograms, and you're going to see this a lot where I give you the solvent in something other than kilograms. But you guys know how to go from grams to kilograms, right? And you can find that way back here at the beginning of the year in your list of prefixes. All right? So, kilo means 1,000. Means you have 1,000 of your base unit. So there's 1,000 grams in a kilogram. So if I wanted to ask how many kilograms is the equivalent of 500 grams, we know, according to this, that if we're going from grams to kilograms, we put grams on the bottom, and in 1 kilogram, there's 1,000 grams. All you got to do is multiply across the top, divide by the bottom. 500 divided by 1,000 is 0.5 kilograms. So you got your moles, you got your kilograms. Let's plug all that stuff into our equation for molality. It's equal to moles over kilograms. We've got 0.073 moles of our solute, 0.5 kilograms of solvent, and let's bust out our calculator again, and we'll say, oh look, it's already there, 0.073, so 0.073, and we're going to divide this by 0.5 kilograms. What's our molality? Boom! 0.146 molal. If you want to be really formal about it, this is a 0.146 molal solution of good old table sugar. All right? Let's flip this around and try it going the other direction. So let me pull up a question here. All right. Here's a good example of an inversion where I'm going to flip this thing around. It says, what mass of solute would be required to make 10 kilograms of a 0.25 molal solution of our old buddy sucrose? We already know this is table sugar. We already know it has a molar mass of 342 grams per mole. How do we know? Because we saw it right up here. Okay, so it's asking for mass of solute. Well, clearly that's the moles part of this equation. Remember that molality is equal to moles over kilograms. Moles of what? Moles of solute. And of course, the kilograms is the kilograms of solvent. So if you're staring at this going, which one is which? The solute is the one that goes on top. The solvent is the one that goes on the bottom. We already know 10 kilograms of our solvent, and we already know the molality, 0.25. If this equation in our triangle looks like this, molality here, moles here, kilograms here, and you already know molality and kilograms, there's only one place to go, and that's moles. It's equal to molality times kilograms. Now, if you're looking for moles of solute, that's easy. And then if you're looking to find the mass from moles, you guys know how to do that too. We've been doing that since chapter 3. So let's set this up because we know we are looking for moles. How do we know? Because what they give us is kilograms and molality, and there's only one option. So we're going to plug it into our equation. Moles is equal to molality times kilograms. We have a 0.25 molal solution, it says right there, and we have a 10 kilogram solvent. That's 2.5 moles of our solute, which is clearly that stuff. That's what goes into our solvent. So how do we do this? If only we had some kind of molar conversion guide. You know, something like this. Something that allows us to go from, say, moles to mass. And if only there was a big pile of these up at the front of Mr. O's classroom that we could just help ourselves to whenever we wanted. You know, something like this. Well, if only. So let's crank this out. We know how many moles of our solute this is, but how many grams is it? We're talking about how many grams, what mass of our solute. This is our solute right here. So, since we know how to go from moles to mass, look what it says. Moles to mass. All it requires is that we multiply moles by the molar mass. So we'll say, what mass of C12H22O11 is equivalent to 2.5 moles of C12H22O11? Well, let's set it up just like this guy right here. We'll put molar mass on the top, 342 grams of C12H22O11 over 1 mole. Bust out my calculator right here. Good thing I brought one, huh? Make sure you have one on the quiz. And we'll say 2.5 moles times our molar mass, 342 grams. There we go. What mass of this solute is required to make 10 kilograms of a 2.5 molal solution? And that's all you do. All right? So take that for a spin. I don't think that's going to give your brains too big of a workout. And if you have any questions, let me know. See you on the next one.